Hi everyone, my name is Nagaraju Kakati. I am working as assistant professor in Marri Laxman Reddy Institute of Technology and Management. I am going to explain about the subject of machine learning, and the topic name is Candidate Elimination Learning Algorithm. So for this Candidate Elimination Learning Algorithm, we consider the two different types of hypothesis. Okay, so one is general hypothesis and second one is specific hypothesis. General hypothesis is represented by the G and specific is represented by the S. These two are considered in the hypothesis of H. Okay, so the general hypothesis is suitable for the negative examples and sample specific condition is for the positive examples. Okay, so the main thing is that how it is differed from the findes algorithm. So for the findes algorithm, we just considered the positive training examples. We didn't consider any negative training examples. Okay, coming to the candidate elimination algorithm, we can consider both positive examples and the negative examples. These two can be handled in candidate elimination algorithm by use of these general and specific algorithms. Specific hypothesis. These two are represented by the G and S. Coming to the positive examples. What I have to consider, yes, I just kept this aside and I just go ahead with the S condition. For each hypothesis S in S, so whenever positive example is there, we try to go ahead with the specific hypothesis. Okay, and negative example is there, I just go ahead with the for G, that is general hypothesis. Okay, so now I considered the one example. After explaining that example, okay, I move on to this algorithm that can be easy to understand this algorithm very clearly. So yeah, as for previous condition, this is general maximally general hypothesis and S is the specific hypothesis. So general, how many training instances we can consider, based on that only we can represent all are by the question marks, and for specific condition all are represented by the null set. So I just considered this particular training example. So enjoy the sport, that is my task at my experiment. For this condition, yeah, here I have the 3 positives and 1 negative example. Okay, so specific condition, first we represent the specific S by the all null sets and general by the all all question marks. Okay, so initially we considered these conditions. Here I just go ahead with the G naught. So initial condition S naught and G naught I considered. What is S naught? S naught is of how many? 6 we considered. Why I represent the 6 here? I have the instances of 6: sky, air temperature, humidity, wind, water, and forecast. Here I have these 6 instances. So for that I represent, or I can consider these 6 question marks and 6 null sets. Okay, so I just represent the S naught and G naught. In the second condition, second step, what I have to consider, yes, I just considered the first example, and I have to check whether it is positive or negative. The first example is positive example. For the positive example, so for this positive example, I just note down the S1. So that means that I replaced my S naught all null set values by these specific instances which are present in my positive example, positive training example. Yes, sky is sunny. Yes, I note down. And next one, air temperature is warm I note down. And next one is normal and strong, warm, and final is same. So based on these values, wind, strong, water, warm, and forecast same. So based on these condition, I just change or update my sample space, specific hypothesis. Okay, next coming to the G1. So here we note down the S1, and next coming to the G1, How could we note down the G1? As per my previous point, from the algorithm, whenever positive example is there, you just remove that G. That means that whenever positive example is occurred for that condition, we just note down the same G value, general hypothesis. So for that, I note down the same value for this condition, that is more general value I note down. Or you get my point? Initially, I start with S naught and G naught. This is most specific and it is most general. And coming to the positive example, all my instances are updated. And coming to this G1 condition, for this positive condition, yes, all I get the same values. It doesn't change. Okay. And next, coming to the next example as example 2. So what is it? What it is? It is also a positive value. So for that positive condition, what about my general value? Yes, it is the same. So for that, I note down the G2 as also by all accepted values, or that means all question mark. Okay, so this is G2. Now we move on to this condition S value. So S is updated here. Yes, S2 from S1 to S2, how it is modified, we will check. So whenever these instances are same, okay, so for that condition, it doesn't change. So here for sky condition, sunny is there. I just note down the sunny as it is. And next, air temperature is warm and warm. So for that, I just note down the warm value same. And next, coming to this, humidity is here normal and high value is there. So whenever the instance is changed, here normal is there and next condition it is high. So for that, I just represent that by the more general value. Anyone can occur, normal or high. It can access the both values. So for that, I represent that instance by the question mark or most general value. And next, third one, strong and strong is there. Yes, same value we can note down. And next, warm and warm is there. And warm also not as it is. And next, same and same. Yes, this is the value. So the S can be specific, hypothesis can be updated for the positive training examples. Okay, is it clear now? So initially we considered S naught and G naught, and S1 is to be curved for positive example, and here G1 is same. Why? Because for positive it doesn't updated, and S2 is also updated. Again, second example is also positive, so for that S2 updated, and G2 is same value. Why? Because this general hypothesis can't be changed for positive training examples. Okay, yes, next move on to the third example. So guys, for easy understanding, I just note down the third example here. Okay, so for third example, what are the values changed here? Yes, S2. For third, what it is negative example. Okay, so negative example means S can be updated or not. S is doesn't update. Why? Because specific hypothesis, just like as our find S algorithm, it can be suitable or it can be considered the only positive training examples. So for that, whenever the negative example is occurred, for that condition, the hypothesis is doesn't updated or altered or changed. The same hypothesis can be repeated. So for that, I note down S2 and S3 are same. Okay, previously we do the same procedure for G condition, G0, G1, G2, all are same. Why? Because for these conditions we get the positive training examples. Here for negative example, S is the same value. And next, whenever negative occurred, yes, G is to be updated now. So for G condition we have to check. So how with this example, yes, what are the changes we occurred? Yes, here sunny is there, it is rainy and warm, cold, and here acceptance is there. Okay, so that can be accepted. And next, strong and strong, next warm, same and change. So some values are altered. What are those? Here these are changes. And warm, strong, yes, acceptance, warm and cold, it is also changed, and sunny. So 1, 2, 3. these three instances or attributes are altered. So based on that, we can note down these general hypotheses. What are the values changed? Sunny is changed, and next one, yes, here warm is changed, and next the third one, weather forecast, that is changed. So we just note down these three different values are the values which are differed or altered with respect to that previous training example to the present training example. Okay, so here these three attributes or instances are changed. So by using those three, remaining all are noted as the accepted values. I can note down these final G3 value. Okay, are you getting my point? Okay, for positive training examples, S is doesn't altered. Okay, sorry, for negative examples, I'm sorry. So for positive examples, S is altered. For positive examples, G is not altered. For negative examples, S is not altered and G is to be updated. Yes. Next condition. For S4, what is the fourth training example? Fourth training example is positive example. So positive example is occurred, that means G doesn't change. Okay, so now yes, G value we can S4 is to be there. So how we can change S4? Sunny and warm are there. Sunny and warm are there. Yes, next here question mark is to be there, strong and question mark, and here also question mark. So these are the values we got for this kind. Whenever change is there, attribute or instance value is to be changed, those are represented by the general value. Okay, so that can be accepted any value. Like that we can note down the S4. Coming to the G4, yes, we can note down, yes, G4. How can I updated these G3? Here I have the three hypotheses. Out of these three hypotheses, I can consider the only two values. Why? Because here I just weather forecast same is to be ignored. We just considered these two as the G4 value. Okay, so why? Because that is already included in this S4 value. Okay, so whenever the hypothesis already repeated or that is also considered here, this particular value indicates the same or change. So this value is to be occurred in this hypothesis. For that, to minimize the number of hypotheses, we can remove that particular weather change value. Okay, so like that we can note down the S4. So the final hypothesis are sunny. What are the changes? Sunny is there, and next warm, strong. So sunny, strong, next sunny, warm, and warm, strong. So these three values, sunny, next change warm and strong. So three different values we have. Okay, so we can note down the three hypotheses as sunny, strong, next sunny, warm, and warm, strong. Okay, A, B, B, C, C, A, just like that. So we can easily note down the most suitable hypothesis. Yes, this is the final hypothesis that can be suitable for the enjoy the sport. Okay, so this is candidate elimination algorithm example. Now I just move on to this particular algorithm. So what I have to do in my first step for candidate elimination algorithm, I just note down the two hypotheses. One is general hypothesis G, and it is represented by the number of question marks based on my training instances, and S is the specific. Yes, all are represented by the null sets. Okay, next for positive examples and negative examples. For positive examples, what I have changed, for positive condition, my S is to be updated with respect to the training examples instances. Negative condition, yes, I just updated these general value training instances. Okay, so for that, for positive condition, yes, my S is to be updated. For negative condition, my G is to be updated. So what we have to do for positive condition? For positive condition, yes, remove from G. Okay, so any value is to be occurred for condition, so those are to be removed from the general hypothesis. And same thing if you observe for the negative example, yes, remove from S. So positive is to be removed from G, negative is to be removed from S. Okay, so the same procedure have to be done for positive and negative. Find S algorithm is purely suitable to the Find S is suitable for the positive training examples, but candidate elimination algorithm is suitable for positive training examples and negative training examples. Okay, so this is the advantage of candidate elimination algorithm based compared to the Find S algorithm. Okay, so guys, I hope you understand the algorithm and training example. Any example is to be, suppose in the examination, if I gave here no and it is S, for that condition what is changed? So S0 is to be normal and S1 is same as it is liquid. For S2 condition, for S2, because of these negative example, S1 and S2 both are same. Okay, so but G condition, G0 we note down and G1 is to be same. Coming to the G2, that is to be updated for this training example. Okay, so any training example we considered, okay, based on those positive and negative responses or positive and negative values, we can update the hypothesis. Okay, so I hope you understand all about this candidate elimination learning algorithm. We will discuss some other topic in my next class. Thank you.